Hi, everyone. Thanks for coming out. So my name's Mark Higgins. I'm the CEO and co-founder of a company called Washington Square Technologies. We've been around for about a year, and we do hosted data and analytics platforms. Today, I'm going to talk about crowdsourced data science competitions. I was tempted to put in the cloud at the end of that, but I thought it might collapse under its own weight of buzzwords. So let's stick with crowdsourced data science competitions. Some background on me. I spent most of my career on Wall Street at banks. I spent 8 years at Goldman as a quant on the foreign exchange and interest rate market making desks, where I did sort of derivatives pricing and risk management kind of stuff. Started a project at JP Morgan called the Athena Project, which is a platform for building financial applications that they use across the bank there now. My co-founder at Washington Square, a guy named Kirat Singh, we went to JP Morgan together, and he also built a similar kind of system at Bank of America. So there's 3 big banks that are using systems similar to the one that we're now building as part of Washington Square. So my background really is as a quant. I got into data science kind of later in my career. I was co-heading JP Morgan's quantitative research group. And after the credit crisis, the focus for banks in quant work moved from the traditional derivatives pricing and risk management stuff and more toward electronic trading, as electronic trading grew in a lot of different markets. And that stuff comes down to a lot of machine learning stuff and data mining and data science. So I started doing it then. And with Washington Square, we got involved with a company called Battlefin that runs data science competitions from the quantitative trading angle, which I'm going to talk about in a little bit. And we've been thinking about how to apply the platform product that we've built to this space. So it's all kind of early days for us doing this. And so this presentation is more here's what we think is going on in crowdsourced data science and where we think some improvements can be made, how we try to approach it, and some lessons that we learned from doing that. And I'd love to hear any ideas you guys have at the end on how to make it better. So the first thing I thought I'd talk about is data science in general. So data science is new. Sort of. I mean, obviously, a lot of the techniques in data science have been around for a long time, and people have been doing really interesting data science work for a long time. But the amount of data that's being generated in loads and loads of different industries over the last 5, 10 years has really kind of changed the game to the point where people who are chief information officers or CTOs of companies like Walmart or McDonald's are having people say, what's our data science strategy? They're trying to hire chief data scientists to try and monetize this vast amount of data they have. That's not sort of traditional stuff. It's not like Google or Facebook where their business is just data science. It's other businesses that are trying to make money off the data they have somehow. So there's a lot of new industries coming into the fray. They have new kinds of problems, new shapes of data that people have to deal with, and kind of best practices and techniques for how to do that are still very much evolving. So it's a really exciting time, I think, to be part of the data science community. One thing I will say, though, is there's a ton of hype about data science. There's lots of, for example, articles in the New York Times about data science. And my wife always says, whenever she reads an article in the New York Times about some new trend, it's probably just ending. So a lot of these companies are trying to hire data scientists. They're trying to get data scientists somehow to do data science on their data. And these aren't like the sort of traditional companies whose business is data science. It's not Google or Facebook or whatever. It's Walmart or McDonald's, right? Or JP Morgan, for that matter. Most data scientists, just because there's so many new people going into data science right now, most of them are quite new to the field, and they've only been doing it for a couple of years. Maybe they're mathematicians or programmers before, and they started to pick up a bunch of data science stuff, and then they said, OK, now I'm a data scientist. And a whole bunch of those people are really good, of course, right? But there's also a whole bunch of those people who don't really know what they're doing. And the problem is, if you're the CIO of Walmart, and you're like, okay, we got to hire a chief data scientist and like make money off our data somehow, it's very hard to figure out who's a good data scientist and who's not a good data scientist. And a lot of these companies have hired data science teams over the last few years, and there's a lot of people who are frustrated, a lot of sort of frustrated executives out there in the corporate world who are thinking this data science stuff is just a bunch of hype because the people we hired didn't do anything. So it's hard to find good data science people for these industries who don't really know anything about data science. The other thing about data science is that like doing it at an industrial scale in a big enterprise is really, really hard. And it's not hard because of any sort of interesting like technical problems, like you know, how do you store your data in an efficient way or anything like that, or how do you send compute to data instead of data to compute, the traditional sort of big data things. It's hard just because of weird organizational issues. So in most big organizations, the data you need to do interesting data science is split across dozens of databases spread out all over the organization. And trying to pull that data into one place so you can analyze it, this takes a long time. It's hard to get through not even really the technical barriers associated with accessing some, you know, Postgres database somewhere in the organization, but the organizational barriers associated with those things. So a lot of the technology teams that have grown up around each database will say, I remember there was this dude like 3 years ago who ran a horrible query against the database and it shut it down so no one else could run anything in production. And so they now say, you're not allowed to run queries directly against the database. You have to go through some API that we built. And they won't even give you that API for like the first 4 months or something. So like those are the kind of issues people have a lot of the time with data science in big organizations. And there ends up being a lot of experimentation. This is the sort of standard data science stuff, right? So when you get a new data set, the biggest problem when you're working on some kind of data science problem, the biggest thing to figure out is what are the right inputs to use. Usually you have to spend a lot of time experimenting around with how you transform the underlying data to get it into something that's useful. Then you have to think about what algorithm you use. And you never end up using sort of an out-of-the-box algorithm. You end up building stuff on top of it and customizing it in all sorts of different ways. You have to figure out what the best training strategy is and how do you figure out if you're overfitting stuff. So the upshot is, like, for these companies that haven't traditionally done data science, actually gearing up a data science program for them is quite hard. So in comes crowdsourcing, right? So the dream of crowdsourcing is that you can just say, well, I don't really know anything about data science, so I'm just going to outsource it to the community, whatever the community is. And from the company's perspective, they like it if it works because they only pay when they get a result, right? So they don't have to like hire a data science team and have that fixed cost and maybe just get nothing out of it. They just pay only when actually they get a result. They just have the prize for winning their competition or whatever. They don't have to figure out how to identify who's a good data scientist or not during an interview process because they don't interview anyone. They just wait for people to bang away at it, and some people end up doing well, and so they probably are good data scientists. So it's pretty good if it works for the companies. To be fair, not that great for the majority of data scientists, since most of them don't get paid for anything. It's only the ones who actually win the competitions who get paid and get hired into cool jobs. But it's good for companies. Some of the reality around it, I mean, it's still relatively early days for this crowdsourced data science stuff. So part of it is this, that it's early days and not a whole lot of people have flocked to it yet. But often it's hard to attract the best data scientists, or even a lot of times the majority of good data scientists to come and join these competitions, mostly because they already have jobs doing data science somewhere. And so why would they spend their free time when they could be hanging out with their kids doing data science competitions? From the company's perspective also, you go into it thinking, hey, this is cool. I don't have to pay anything until someone solves my problem, and then I pay them a prize. But in fact, to run a competition is kind of a pain in the ass. Like, you have to actually manage the competition. You have to interact with all the actual data scientists who are doing stuff, you have to get their data. You have to make sure they don't try and game your competition. You have to evaluate the results at the end. And so you need someone in your organization who's the point person for running a data science competition. So in the end, you still have someone in your organization who you have to pay to do it. That said, competitions are happening. The first one that I know of, and I'm not that close to this, so maybe there was another one, but the first one I know of was the Netflix prize that was any kind of scale. So the idea with this is in fall 2006, Netflix started a competition to say, come up with a recommender engine for movies that's better than the one we already have, and better as defined by a specific metric, and to win it, you had to be at least 10% better than theirs was. It took 3 years for that competition to play out, and eventually the combination of 2 different teams who were doing it ended up winning it for $1 million. So it was a nice chunky prize, but it was just once and it took 3 years. Nowadays, it's a lot more industrialized. So I think the biggest right now is Kaggle, which I know there's Kaggle people here talking at this conference. Kaggle, I think, is the biggest crowdsourced data science platform today. If you look on Kaggle.com, there's sort of around order 10, maybe 20 competitions going at any time. They have cash prizes anywhere from nothing to 100K for the biggest prize. So data scientists can join those competitions because for some of them, they get paid. And also, it's kind of a recruiting platform. And this is one cool thing about the crowdsourced data science stuff is if you do a good job in one of these competitions, then it's a way of just getting noticed. It's like a super ramped up resume where people who actually care about data science are looking and see you winning data science competitions, and they want to hire data science people. So it's like a good way of showing that you know your stuff, even if you don't have kind of a traditional academic background, right? Like, say you're going to try and get a job at a quant trading hedge fund like WorldQuant or something. They typically just go and like hire from like MIT and Harvard and stuff like that. So if you're some dude in Pakistan and you want some way of getting noticed, this is a nice way to do it through these kind of democratic processes. Battlefin is another one that I think is doing some interesting stuff. So these guys we've worked with, my company we've worked with directly. They run data science competitions, but they're focused on quantitative trading rather than Kaggle, which does sort of generic, optimize whatever they're interested in competitions. These guys do quantitative trading. So where they have their edge is they work with data vendors that have kind of non-standard financial data. And these people generate data, and they want to figure out, are there trading signals buried in my data somewhere? And they want to crowdsource a bunch of data scientists to try and find those trading signals. So as an example, one of the companies that they work with is iCentium. So iCentium looks at Twitter tweets that reference equities, and they have a natural language processing algorithm that goes and assigns a sentiment score to each one of the tweets. And their product is basically like a real-time feed. Tweet comes out, they process it, generate a sentiment score, and publish their own tick of sentiment for whatever that name is. And so they've got a big whack of historical data based on this stuff, and they want to have people go and bang away at it and see if they can come up with trading strategies using it. The winners of those competitions get cash prizes. They also, Battlefin runs a hedge fund incubator. So basically what they do is they say, if you do well in the competitions and we like you, then we'll fund you with $250,000 of capital so you can go and have your own little hedge fund or your own portfolio as part of our hedge fund, which is good. Like I was saying, a lot of these people who come from non-traditional backgrounds have a hard time getting a job, say, as a portfolio manager at a big hedge fund. This is a nice way, especially in the current environment where hedge funds have been beaten up for a few years, for people to build a track record so they can go and sell themselves as a portfolio manager later on. So that's one of the ways that Battlefin tries to incentivize data scientists to come and join their competitions. And also, kind of like Kaggle, it's a recruiting platform, so they'll go and, Battlefin works with some of the big hedge funds, like quant trading hedge funds, and if they find good data science people or teams, then they can go and plant them at the big shops. Quantopian is another one that's really big now. I think there's a bunch of Quantopian people here at this conference too. So Quantopian also runs these quantitative trading competitions. They use more standard data sources than Battlefin does, so sort of equity market data and fundamentals data and stuff like that. But they have a humongous community of people all working on this. And kind of like what Battlefin does, the winners of the Quantopian competitions end up getting funded as part of Quantopian's hedge fund. Some of the problems, I think, that exist with the current state of crowdsourced data science. Companies that the first one, companies that have the data don't really want to participate at scale with these things. And part of that is they're just worried about sending their data into the wild. So if you want to join a Kaggle competition, you go to kaggle.com and you click on the link and download the lump of data and just start working on it on your computer, which makes it really easy to get involved. But Walmart's never going to post their in-store sales data for all their sales on kaggle.com. Right? They're just not going to release that valuable data out into the wild like that. And current platforms generally don't have a whole lot of controls, if any controls, on how the data is distributed, how people are storing it once they have it, or rules on what they do with it after the competition's over. Like people would want the data scientists to delete it, and they probably don't. There's a lot of worries about people gaming these competitions as well. Anytime you have a competition and there's a cool prize at the end of it, people will not always, I mean, they're incentivized to win the competition, and that's what they're incentivized to do, right? So if they can do that by gaming it, then they'll probably try and game it. And like I mentioned before, there is overhead associated with running these competitions, which can sometimes be significant. Second point, not a lot of experienced data scientists are taking part. Like I said, part of that is because they already have full-time jobs doing other stuff. But part of it is also because there's a fair amount of overhead to get started as a data scientist with these things. You download the data, but then it's just kind of the raw data in a CSV file or something, and you need to reshape it to fit whatever machinery you're using to do your analysis. Also, say you're doing a quant trading competition, and you want to look at 2,000 different equities all at the same time. Doing training on that stuff can be pretty expensive. So often you'll want to, like this running that on your desktop, often it doesn't give you enough compute. So computational costs can sometimes be pretty significant with these things. And finally, the time frames for these competitions are pretty short. They're usually like a few months. And so being able to solve all those problems of like getting the data in the right shape and being able to run all your analysis in enough time is tricky, especially because people are often doing these things in their free time. One last problem that is true for some competitions and not for others is that it can be hard to scale. So for quantitative trading competitions, for example, what you'll want to do is say, here's a bunch of training data. Go and train your algorithm on it, and you have access to the training data for your training. And then we've got like our competition data off to the side. That's a different time period, say. And we're going to take your algorithm and bung the competition data through it to get your final score to see if you win the competition. What that means, though, is if I'm running the competition, I have to be able to run all your programs, right? So say like one of you likes using R. And so you write your stuff in R with a bunch of custom packages that you put together. And you assume that the data lives in C:\data science competition mark. And it's got a name, foo.txt or something like that. Like, whenever that individual person has a really complex, really bespoke little environment set up on their computer, that you then have to like try and say, okay, now send me your program, and I have to run it on my end with the competition data somehow plugging into your thing. And it usually takes like a few weeks of back and forth to actually get the program to run on the data the right way. So it's hard to scale. It's hard to get more than a kind of handful of data science people doing it for any individual competition. So this is where we thought we could build something interesting at Washington Square Technologies. So we have a product called Beacon, which is a cloud-hosted data and analytics platform. So our idea with trying to kind of improve the state of these data science competitions is we say, we've now got this hosted platform. So it's like a walled garden. And what we're going to do is say, data owners, go and stick your data inside our platform. We'll put it behind a locked door. It's inside of our platform. People can't take it out. So it's in our platform. We'll give the key to people that you say it's OK to give the key to. And when the competition's done, we take the key away from them. Right? So data owners will feel a lot more comfortable that the data that they associate a lot of value with won't be this sort of escaping out into the wild. Data scientists have to do all their stuff inside that walled garden, though. So they have to write all their code. They have to run all their code inside that garden. And the data scientists, when they build like a function to actually analyze the data, they have to build it according to some pre-specified interface. And the reason for that is that lets us scale up to a whole bunch of people running all in the same competition. By the way, this is an open data science competition, so this isn't particularly open. It's kind of a closed, walled garden. But I think it has some value, though. So I'll get into the details of that a little bit more. I thought I'd just quickly talk about what our platform is, though. So like I mentioned, I started off at Goldman Sachs, where we were using this platform they'd already built called SecDB, and we were building that out. Then we built a platform called Athena at JP Morgan and built another platform called Quartz at Bank of America. And so our Beacon platform shares a lot of the same kind of architectural principles as those things, but taking advantage of a lot of the cool modern stuff that's out there, like infrastructure as a service, right? So people shouldn't have to buy computers and wait 12 weeks for them to get delivered to their data center anymore. Now you can just go and rent compute by the hour from cloud providers. This wasn't, when we first put it together, this wasn't designed to be any kind of data science platform at all. It was designed to be a platform for quants and developers at financial institutions to do sort of interesting financial analytics. So, for example, insurance companies do a lot of complex analytics around managing life insurance positions, bonds that they hold as hedges, derivatives that they hold as hedges for those things, and running all that stuff through a bunch of different market data scenarios. So our platform is used for that. Banks have a lot of analytics around calculating capital, which are fairly complicated post-crisis, as well as quantitative tools that they provide to investors. Like if you're a wealth management client, they might say, OK, here's like a projection of your wealth looking out until you're 90 or something. So they have a bunch of models that are behind that. Hedge funds. So we have a client who's a hedge fund trading sort of complex options and cross-asset stuff, and so our platform gets used for that. Or we have a client that's a financial technology startup that's wanted kind of an accelerated start, and so we say, here's a platform. You can host your web applications there. You have access to elastic grid compute. And basic financial models, and so they can quickly get started and build something interesting. So the target audience for our platform is not like end users, it's quants and developers, like a development and production platform. So people who use it, they write code in it, access data, run all their analyses. They can build applications. They can kind of script out applications pretty easily, all inside one integrated environment. So it's not like you're hacking around in Excel or running stuff on your desktop. Everything you do is inside this one platform. And to do that, it has a lot of interesting tools that make it easy for developers and quants to be productive. The main language we use is Python. That's because we've used Python a bunch before. It's got a lot of really nice high-level packages to do zillions of different things. We also support C++ add-ins and use JavaScript and HTML5 for user interfaces. So when I say a platform, there's a lot of pieces to a platform, I think, to make it a useful and interesting thing other than just saying, why not just use PyCharm for your IDE, right? So it's got to have things like version control integrated with the IDE. You have to standardize on things like a common glue language to pull everything together. You need to have a good controls architecture so you can actually use it in enterprise environments. It has to be a production environment that's different than your development environment. Has to have clean interfaces to data and make it easy to get the data that you need in a consistent way. It needs to have access to compute so you can do large-scale grid computing. We have a job scheduler so you can do batch computing easily, grid scheduler so you can access that compute, and then tools for doing reporting and building out applications. So all this stuff is accessed through a web browser. It's layered on top of cloud providers or local clouds. We built a lot of stuff on top of the infrastructure as a service stuff, so it's really easy to spin up like hundreds of machines that are all identical to each other that all have the access to the same stuff. We built some pretty clean interfaces to elastic compute. So like as a quant, I don't know anything about like how to construct a new Amazon machine. I just want to say like, here's a function that takes an argument, run that function with like 10,000 values of the argument, and give me the results back somehow doing it efficiently. So that's the kind of thing our platform makes it easy to do. And then we have integrated object-oriented database as kind of a data fabric that you can easily access most types of data from, and a way to build applications and deploy them as web applications. So for the data science stuff for us is kind of like an interesting sideline that we're hoping will grow into something more. We're focused on quantitative trading problems to start. So rather than sort of the broader world of data science stuff like Kaggle, it's more the quantitative trading data science stuff like Quantopian or Battlefin. And like I said, the idea is the data owners store their data behind locked doors in Beacon. So that avoids the problem where data owners have to give all their data away to just like random people on the internet. And you can cut off access to the data once the competition's over. And the data scientists write and run all their code inside of Beacon. One of the benefits of doing that is the data is already in Beacon, and we've already built clean interfaces on top of it to get it out. So you don't have to worry about like structuring like downloading and structuring up the data. That's already kind of done. And there's nice demos and frameworks for each competition that make it easy to access the data you need for that competition. So it's relatively easy to kind of get geared up as a data scientist as well. So the benefits is that data owners become more willing to provide their sensitive and valuable data to people. Data scientists have a lower barrier to entry. You don't have to worry about data setup, and there's sort of clean interfaces for what you need to build. And because when the data scientists actually build stuff, like build functions to generate trade orders, in the case of quantitative trading, they have to build it according to a specific interface. So that means as the organizer of the competition, I don't have to go and work with each individual data scientist to figure out how to run their program on the competition data. They already have to build their function according to the right specs to start with, and then the competition data can just feed straight into it. So it's easy to scale up to lots of different competitors. In terms of what we actually did, we worked with this company, Battlefin, on a round of competitions just to kind of test out this approach. So we did it with data from this company called Isentium. Like I said, they do Twitter sentiment analysis for equities. So we've got 7 data scientists using Beacon for this trial. So not that many. Enough that we can actually talk to each one and figure out how they're doing in the platform. So the idea is we host training data that the competitors can access. So this is market data and Isentium data, real-time data, so minute bar data for equities and real-time ticks for the Isentium data, from 1st of January 2013 through 1st of September 2014. We anonymized the equities, right? So we changed their names to like S1 through S2000 or whatever to help prevent gaming. Because, I mean, the problem with quantitative trading stuff is the training period is 1st of January 2013 to 1st of September 2014. There is basically no Twitter data before January 2013. So you can probably pretty much guess the competition data is going to be from 1st of September through something after that, right? So if you knew that Apple was one of the companies in the list, you could just go and look at the performance of Apple from 1st of September on out and say, Apple went up a lot. I'm just going to like fudge around with some fake strategy until this buys Apple at the beginning of the period and game it that way. So we ended up having to anonymize the equities data by changing the names and a few other little tricks. And then we have tick data for the iCentium stuff where the names of the equities are also changed to match the anonymized equities data. Then the competitors, their job is to build a function that essentially takes in a tick of data, whether it's market data or iCentium data, and analyze it and either spits out nothing or a trade order. And so they can run that against the training data and see how they perform against the training data. Then we can just take our competition data, the judges' data, and run it through the function and see how they perform for their official score. And that judges' data isn't available to the competitors. So some of the results from this, some are like pretty good, and some are kind of a little bit depressing. So having a standardized platform really does deliver some of the things that we thought it would, in the sense that it makes the data owners a lot more comfortable about putting their data into these kind of competitions. It does make it easy to build new strategies and quickly try out new things because the interfaces to the data are pretty smooth. It's easy to scale to new competitors and add new people in. And it is easy for these guys to access all the elastic compute stuff so they can run their strategy, say training in parallel against a whole bunch of different names relatively quickly. So that was all good. That was kind of what we hoped it would do. But one thing that became clear is that it's kind of a pain in the ass for the data scientists to learn a whole new platform, right? So it's a platform, which means there's a lot of stuff in it. It's not just like a new IDE. It's a whole set of tools that you have to know how to use to do stuff the right way. So we ended up having to work with each of the competitors to get them to understand how to use the platform. So there is that same kind of overhead that we hope to avoid, sort of like scaling linearly with the number of competitors. But in this case, it's helping them understand how to use the platform. Beacon currently forces competitors to use Python or C++, and really Python. And that's good for some people who like using Python. Like more and more people are using Python for data science stuff these days. But still, there's a big whack of people who prefer to use R or MATLAB or SAS or just write their own stuff in C. And so it was hard to get those people to take part in the competition. One thing we found is competitors are generally quite nervous about making their code available at all to anyone, whether it's us as even if it's us, like the competition organizers. We're not developing strategies or anything like that, but they're worried about us being able to see their code. Some of them are anyway. Some of them don't care, but some of them do care. The last thing, which is sort of an interesting one, is, and maybe this is a solved problem, but I don't know the answer to it. So the traditional sort of big data compute paradigm, well, the little data compute paradigm was you have a database and you have a bunch of computers that do the compute. They each suck the data that they need into the compute. So you send the data to the compute and it does the computation. The big data stuff kind of turned that around and said, send your compute to the data. So shard your data out into a whole bunch of different pieces, send the compute to compute on each piece. With elastic compute, though, it makes that last thing kind of hard because you know, the traditional notion of saying I've got a big cluster of machines, I've got my data sharded out, I know where to send the compute for each individual bit of data. That works when you've got kind of a fixed cluster of machines. When you have elastic compute, though, when you're spinning things up and then dropping them back out, when you're using spot instances that might just disappear, it's a little bit harder to figure out how to do that. So that may already be a solved problem, but I don't know what the answer is to that one. The way we ended up doing it was just super simple. We just ended up using flat files, using HDF5 to store our data. And we just bucketed it up in ways that were useful for that competition, like bucketed it up by equity name and by time period, essentially, so that it was efficient to access it for the different compute nodes. All right, so I think that's the end of what I wanted to talk about.